Namaste dosto. Imagine you're trying to unlock a secret code that works every single time, no matter what numbers you plug in. That's what trigonometric identities are. Magical equations made from sine, cosine, tangent, and they're friends that hold true for all values allowed by their definitions. Why do we need these identities? Well, they help us simplify tricky trigonometric expressions and solve equations that pop up not just in textbooks but in real-world problems too. Think of them as trusty shortcuts. These identities come straight from the definitions of our favorite trigonometric ratios and rely deeply on the Pythagorean theorem, which you know as a fundamental rule for right-angled triangles. So today, we're diving into how these identities work and why they're so important. Ready? Let's go! Let's build on what we just saw with something fundamental. The Pythagorean identities. Picture the unit circle, that perfect circle with radius 1, and recall the Pythagorean theorem from geometry. A squared plus b squared equals c squared. Here, the most basic trigonometric identity mirrors this. Sine squared theta plus cosine squared theta equals 1. Say it with me slowly. Sine squared theta plus cosine squared theta equals 1. This means if you square sine theta and add it to the square of cosine theta, you always get 1. Now, what if we divide both sides by cosine squared theta? That gives us a new identity. Tangent squared theta plus 1 equals secant squared theta. And if we play the same game but dividing by sine squared theta instead, we get 1 plus cotangent squared theta equals cosecant squared theta. Remember, these identities work as long as the denominators, cosine or sine, are not 0 because we can't divide by 0. So, these three are like the pillars of trigonometry, holding up many more complex relationships. Let's put this into practice with an example. Suppose we know sine theta equals 3/5 and theta lies between 0 and pi over 2. Meaning, our angle is in the first quadrant where all values are positive. We want to find cosine theta. Using the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. We can find cosine theta by rearranging it as the square root of 1 minus sine squared theta. That is, cosine theta equals square root of 1 minus 3/5 squared. Calculating inside the root, 3/5 squared is 9 over 25. So 1 minus 9/25 gives 16/25. Taking the square root gives us 4/5. Great job. So, cosine theta is 4/5. This also lets us find tangent theta, which is sine theta over cosine theta. 3/5 divided by 4/5, simplifying to 3/4. Fantastic. Next, we explore how tangents and cotangents relate directly to sine and cosine. These are called quotient identities. Simply put, tangent theta equals sine theta divided by cosine theta, and cotangent theta is cosine theta divided by sine theta. Alongside these, reciprocal identities express certain functions as reciprocals. For example, cosecant theta is 1 over sine theta, secant theta is 1 over cosine theta, and cotangent theta is 1 over tangent theta. These identities form the backbone of many trigonometric transformations, helping us switch from one ratio to another when simplifying expressions or solving equations. Remember, they're your reliable toolbox for trig problems. Let's verify a simple but powerful identity now. We want to prove that the fraction 1 minus cosine squared theta over sine squared theta equals 1. Look at the left-hand side. It's 1 minus cosine squared theta divided by sine squared theta. Recall that from the basic Pythagorean identity, sine squared theta equals 1 minus cosine squared theta. So, the numerator becomes sine squared theta. Putting it back in the fraction, we have sine squared theta divided by sine squared theta, which is exactly 1. So, the right-hand side is 1, and the identity is proved. Areva, isn't trig neat? Time for another example. Given that secant theta is 13/5, with theta again in the first quadrant, find sine theta. Since secant theta is the reciprocal of cosine theta equals 5 over 13. Using the Pythagorean identity again, Sine squared theta equals 1 minus cosine squared theta. Calculating cosine squared theta, we get 5 over 13 squared, which is 25 over 169. Subtract that from 1, we get 144 over 169. Taking the square root, sine theta equals 12 over 13. Excellent work. Let's verify a slightly more complex identity. The fraction 1 plus tangent squared theta over 1 plus cotangent squared theta equals tangent squared theta. Remember the Pythagorean identities. 1 plus tangent squared theta equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. Substitute these into the left side, so it becomes secant squared theta over cosecant squared theta. Express secant and cosecant in sine and cosine terms. Secant theta is 1 over cosine theta. Squared it's 1 over cosine squared theta. Cosecant theta is 1 over sine theta. Squared it's 1 over sine squared theta. So the fraction is 1 over cosine squared theta divided by 1 over sine squared theta, which simplifies to sine squared theta over cosine squared theta. That's simply tangent squared theta. So the left side matches the right side perfectly. Shabash. The identity is verified. Why do we care about all these identities? Because they are truly useful outside the math book, especially in geometry. Trigonometric identities help us find relations in problems involving heights and distances, like figuring out the height of a tree using shadows or the distance across a river. Using tangent theta as height over base often simplifies complex triangles into manageable right triangles. The Pythagorean identities let us eliminate extra variables or check if our calculations make sense, ensuring the consistency of triangle measurements. In short, these identities are like your geometric compass and ruler combined. Let's quickly recap today's important identities and ideas. First, sine squared theta plus cosine squared theta equals 1. Next, 1 plus tangent squared theta equals secant squared theta. And finally, 1 plus cotangent squared theta equals cosecant squared theta. Remember, these identities are always true equalities involving trigonometric ratios. They come from right triangles and the unit circle, and help us simplify expressions or solve equations easily and algebraically. Beyond the classroom, these identities support real-world tasks in geometry and physics, making them essential for your exam prep and beyond. सोच कर देखो how understanding these formulas can help you solve problems faster and with confidence. Keep practicing and shabash on your journey through trigonometry.